signal transduction in bacteria, bacterial virulence factor, cell biology, host-pathogen interaction. He did his PhD from Patel Chest Institute, University of Delhi. He served as scientist and chief scientist in CSIR IGIB, and he has received several prestigious awards like Best Mentor Award of Indian Institute of Science. He is J.C. Bose National Fellow, and he is Fellow of different national and international societies like Indian National Science Academy, Association of Microbiologicals of India, National Academy of Science, National Academy of Science 2010. Now I hand over this mic to Professor Sethi.
Screen. Dr. Gautam, can you hear me? Hello? So Dr. talking on Gautam Sethi, So Dr. Gautam, please. Dr. Gautam, can you hear me? Yes, I can hear you. Good morning. Yes, good morning. I can hear you. This session. So Dr. talking on Gautam Sethi, session. So
Good morning. Can you see my screen?
yeah, we can see your screen. Please go ahead.
Good morning. Can you see my screen?
Yes, we can. Yes, we can. We can see the screen. Can you speak little loudly? Can you write a message, please? You cannot hear me. Can you speak little loudly? We cannot hear you.
Okay, good morning. Now can you hear?
Yes, we can. Thank you.
Okay, thank you. Good morning to all of you. First of all, I would like to thank the organizing committee, Professor Alok, for his kind invitation in this prestigious meeting. And it's due to some urgent work, I could not attend the physical meeting, but today I will be presenting my talk online on targeting oncogenic transcription factors STAT3 for cancer therapy. So I will begin with a slide showing a wide global variation in cancer incidence and mortality. So if you see in this slide, on the left hand side we have US, and there are more cases of lung, breast and prostate cancer in North America, which has an aging population. If we move to Europe, the trend remains more or less the same. And if we talk about Southeast Asia, including India, so we find that lung and oral cavity cancers are the most common among men, while cervical and breast cancer are the most common among women. So there was a study published in Science a few years back, which demonstrated that in addition to the various risk factors for cancer that we already know, which include environmental factors, genetic factors, and lifestyle-related factors, bad luck has been contributed to be an important risk factor or connection to cancer. And bad luck implies just the random mutations that occur during the process of DNA replication in non-cancerous stem cells. So this is the latest study published in Lancet in 2022, in which the authors have estimated the cancer burden that can be attributed to different behavioral, environmental, occupational, and metabolic risk factors. And what they found that leading risk factors that can be attributed to cancer mortality worldwide was smoking, followed by alcohol use and high basal metabolic index. So based upon this study, it was again re-established that the leading risk factors contributing to global cancer burden in 2019 were behavioral, whereas metabolic risk factors saw the largest increase between 2010 and 2009. So this has been our working hypothesis from the last few years after I completed my postdoctoral training at MD Anderson Cancer Center under Professor Agarwal. So we have looked at the contribution of different lifestyle, environmental factors, and we expect that they play a very important role in the process of inflammation, and they can function by inducing acute inflammation, what we call it as therapeutic inflammation, and chronic inflammation, which has been linked to various hallmarks of cancer, including tumor cell survival, proliferation, invasion, angiogenesis, etc. And this is what we call it as pathological inflammation. So in recent years, in my lab at NUS, we have looked at also the role of non-coding RNAs and how they can mediate the process of inflammation in various chronic disease. So this is our recent article showing the role of non-coding RNAs in regulation of inflammation and also the role of non-coding RNA and macrophage interaction in tumor progression. So recently we have done a lot of work using prostate cancer as a model, which is the second most common cancer diagnosed among men worldwide, and it is the fifth leading cause of mortality. And if we talk in Singapore context, it is the third most common cancer affecting Singapore men and sixth leading cause of mortality. And in recent years, it has been found that prostate cancer along with breast cancer cases have risen sharply in Singapore. And for example, prostate cancer, it is now among the top 3 cancer. Previously, it was at the 7th place almost 14 years ago. So what is the prostate cancer? So it arises in the prostate gland of man, and it's a slow-growing tumor. And one of the most important risk factors is that of old age. And globally, I have shown you it is the second most common cancer and third most common cancer among Singapore men. And the screening involves combination of prostate-specific antigen levels and Gleason score. So if you look at stages of human prostate cancer progression, it involves loss of basal lamina, where we have this inflammatory condition called prostate intraepithelial neoplasia, loss of basal lamina, and then we have this condition called invasive carcinoma, which is managed by treatment with anti-androgens. But unfortunately, it is anti-androgen therapy is not curative, and prostate cancer acquires a state, what we call it as androgen independent state, and then undergoes metastasis. So if we look at the current risk factors for prostate cancer, it includes aging. So most of the patients are above 70 years of age. Family history, if you have a first-line relative, your risk may increase by twice, and ethnic origin. So initially it was found to be more common among Western men, but of late the incidence has been increasing in Southeast Asia as well. So if you look at the current therapies for prostate cancer, they are based on PSA level greater than 20, Gleason score more than 10, or metastatic disease. And if the Gleason score is less than 6, we put the patient on active surveillance. And then other options include surgery, radiation therapy, androgen deprivation therapy. But once the patients are non-responsive and we have this castration-resistant prostate cancer, we have very limited treatment options available, one being docetaxel, which is a microtubule inhibitor. So if you look at the current treatment therapies, they depend upon the clinical behavior of prostate tumor. It is organ confined, and we have radiation therapy, surgery. For locally advanced tumor, we have androgen deprivation therapy, but in case of CRPC, there are not many chemotherapy and targeted therapies available, and hence there is an urgent need for identification of pharmacological agents to improve the existing treatment modalities, and agents derived from Mother Nature can serve as important source of anti-cancer drug, and that is also one of the main theme of this conference. So recently we have edited a number of special issues in prestigious journals like seminars in cancer biology, looking at the molecular targets of natural compounds for cancer treatment and prevention. And this is one of the latest one which we have edited in May earlier this year. So today I will share the work done by my lab on this plant which is indigenous to the Asian subcontinent. It is known as neem or Antagata indica, and it is also known as wonder tree, nature's drugstore or village pharmacy. And we already have a number of neem products in the market which have been used for management of different conditions, and also a wide variety of bioactives have been identified from neem, which include nimbolide, nimbane, etc., which have been used for management of different diseases, including respiratory diseases, inflammatory conditions, etc. So we have compiled a number of articles looking at the anti-cancer potential of neem for the management of different diseases, and also strategies to evaluate the pharmacokinetic potential and how we can improve the pharmacokinetic potential of nimbolide to accelerate its clinical development. So there are several reports that have looked into the anti-cancer effects of nimbolide in different cancers, including prostate cancer, where it has been shown to induce apoptosis. But in our 2 studies that we have published, we have looked at the anti-cancer effects in detail using prostate cancer model, cell lines, and transgenic as well as orthotopic model. So I will quickly go through these studies. So first I will start with the in vitro studies. So first we look at the viability of different prostate cancer cells, DU145, LINCAP, and PC3. And DU145 and PC3 are androgen independent. We found like nimbolide can suppress the viability at a very low IC50 at 72 hours. It can induce apoptosis. So we have done the standard techniques like Western blot, looking at GFAR, caspase-3, and you can see a significant apoptosis by nimbolide. Then we look at the cellular invasion, looking at the McNeil assay. You can see a significant separation of invasion by nimbolide alone, and even in the presence of the chemokine CXCL12. We observe similar effect while looking at the migratory potential of prostate cancer cells using bone healing assay, and again CXCL12 induced migration was suppressed by nimbolide. Then we proceeded to carry out in vivo studies on anti-cancer effects of nimbolide. So we have developed a transgenic mouse model, which is a transgenic adenocarcinoma of mouse prostate model. This is a transgenic animal model in which we have used this oncogene SP4PP antigen, which is expressed specifically in the dorsolateral prostate. So we have developed this model in my lab, and we have used this model because the stages of this model closely resemble the histologically and biochemical nature of the disease in human. So you will see when we use this model, you will see the formation of epithelial hyperplasia at 8 weeks, low ping to high ping vague in 12 weeks, fecal adenocarcinoma 12 to 18 weeks, and differentiated carcinoma in 24 weeks, and followed by metastasis at 28 weeks. And if you castrate this mice at 12 weeks, it does not affect the primary tumor development or metastasis in my clamp mice, thereby it is parallel to the emergence of androgen independent state that we see in them. So using this mouse model, we divided the mice in 3 different groups at 4 weeks, between 4 to 12 weeks, 12 to 18 weeks, and 24 to 30 weeks. We looked at neoplasia, cancer progression, and metastasis. So we also did a pharmacokinetic study and selected these tools which was bioavailable in the serum by oral gavage to be administered to mice, and control mice were given the normal diet for the period of the study. So if we look at the H&E staining, we found like nimbolide treatment can suppress the formation of thin, well-differentiated carcinoma and poorly differentiated carcinoma. And if we look at the tumor growth and metastasis, we can also see that it can suppress the tumor volume and metastasis to the lungs and liver. So we also looked at the tumor tissues and evaluated the effect on proliferation and apoptosis markers. So we can see an increased apoptosis as evident by cleavage of caspase-3 and also a reduction in the level of Ki-67. So we also conducted an acute toxicity of nimbolide. So we saw that there is no significant effect at this dose on the relative body weight, levels of different enzymes like ALT, AST, burn, and also the morphology of the normal prostate is not affected. So then we proceeded to look into the molecular mechanisms. So we are interested in this family of transcription factors, which is known as STAT, which are present in an inactive form in the cytoplasm, and there are 7 different genes which play a very critical role in cytokine-mediated signaling. So we have looked at the role of this transcription factor in different diseases and published a number of articles. So this is a recent review article showing that it can be activated by different stimulus, including cytokines, growth factors, different kinds of TGF-beta, oncostatin M, and binding of, for example, IL-6 to IL-6 receptor can lead to activation of JAKs, which can then phosphorylate STAT3 and induce their dimerization and nuclear transportation. So in case of prostate cancer, we have also found like STAT3 is constantly active in prostate cancer tissues, which have been derived from the patients. And we can see an increased level of both phospho-STAT3 and STAT3. And and the role of STAT3 in prostate cancer has been reported previously, showing that it can promote proliferation and acting as a growth survival factor. For example, it has been shown that if you activate STAT3, it can protect the cells from apoptosis due to androgen deprivation upon administration of androgen deprivation therapy, and it can also enhance androgen receptor function in an androgen independent manner. So looking at the connection between the activation of STAT3 in prostate cancer, we checked the effect of nimbolize. So we saw by Western blot that it can suppress STAT3 activation as well as by DNA binding. We established that STAT3 at tyrosine 705 is the specific target of nimbolize, whereas other STAT isoforms are not affected, as well as phosphorylation at serine 727. We also showed that activation of upstream kinases, phospho-JAK1, JAK2 is inhibited in both DU145 and IL-6 induced link gap cell line. We also looked at the levels of STAT3 regulated gene products by Western blot and real-time PCR analysis. So we established that nimbolize can inhibit STAT3, but there was no mechanism in it, like how it is inhibiting STAT3, it is not known. So we went back to the literature review and found like nimbolize is a very potent antioxidant. So it is more potent than vitamin C. So we wanted to check whether this ability of nimbolize to modulate ROS can be linked with its potential to inhibit STAT3. So we all know ROS plays a very important role in a number of physiological and pathological processes. So if you can say, so ROS level once deregulated due to overproduction of reactive oxygen species or imbalance in the antioxidant system, it can lead to a number of pathological and chronic diseases. So we wanted to establish the possible connection between nimbolize, ROS and STAT3. So to our surprise, we found that if we treat the cells with broad spectrum antioxidants like NAC or glutathione, the STAT3 inhibiting effect of nimbolize can be reversed. So contrary to the previous reports that nimbolize is acting as an antioxidant, we evaluated whether nimbolize can induce ROS production and whether this ROS is contributing to the STAT3 inhibitory effects of nimbolize. So indeed we found that nimbolize can induce ROS accumulation in prostate cancer cells. So if you see here, you will see a significant increase in ROS, and we also identified the ROS species. The ROS species here was hydrogen peroxide and not what we see generally hydroxyl radicals. So we also showed that ROS accumulation is driving the apoptosis by nimbolize. For example, if we scavenge the ROS using NAC or GSH, we can see a decrease in the apoptotic potential of nimbolize. So you will see by flow cytometry and Western blot analysis. So next, we investigated that how nimbolize can increase ROS levels. So if you can see, we have tested these two broad spectrum antioxidants. And if we look at the cellular mechanism, so this glutathione system is a major antioxidant which is responsible for removing H2O2. So it can convert H2O2 into water and oxygen, and this reaction is catalyzed by glutathione reductase, which can reduce GSHG to GSH, and GSH acts as a negative regulator of the redox stress and can replenish the normal functions of the cell. So we wanted to check whether nimbolide can affect the glutathione system, which in turn is leading to increased production of ROS. So indeed, we found like nimbolide can inhibit the glutathione, this expression of this enzyme glutathione reductase, and promote cause an imbalance in the ratio of GSHG and GSH. So it reduces the level of GSH, whereas it increases the levels of GSHG, which is an oxidized form of GSH, and thus leading to imbalance in oxidative stress. So next, we wanted to test how nimbolide is affecting glutathione reductase. So we did a protein expression. By Western blot, we see that the protein expression of glutathione reductase is not affected. This activity of the enzyme in the cell-free assay.
Dr. Gautam, you have got 5 more minutes.
Yeah, I will try to finish in 5 minutes. So the kinetic activity of nimbolide, of the glutathione reductase, was affected by nimbolide in cell-free assay. So in this study, we concluded that nimbolide is directly inhibiting the activity of glutathione reductase, an enzyme which is involved in scavenging of ROS or H2O2 by activating the glutathione system. So as a result, it leads to GSHG, GSH imbalance, leading to increased production of ROS, which can then suppress STAT3 activation, leading to apoptosis, inhibition of proliferation, and metastasis, as I have shown in my previously in vivo data. So recently, we have completed another study looking at the effect of nimbolide in combination with chemotherapy in prostate cancer. What we found, like the patients who are resistant to this androgen deprivation therapy, they are generally treated with docetaxel. So we use this recent study to see whether nimbolide can enhance the effect of docetaxel in prostate cancer cells. So we have used these docetaxel resistant cell lines and treated them with combination of docetaxel and nimbolide, and you can see an increased apoptosis. We also found like docetaxel can induce this NF-kappa B activity in docetaxel resistant cell line by increasing P65 phosphorylation, and if we treat with nimbolide, this docetaxel induced NF-kappa B activation can be reversed. So in this study, we have used 2 different mouse models. So we have developed an orthotropic mouse model with luciferase tagged link cap cell line. So using this model, we have demonstrated that if we use a combination of nimbolide plus docetaxel, we can see a significant inhibition of tumor growth as well as metastasis to the lung and liver. And we have also done some study, Western blot and immunohistochemistry, and showed an increase of deep caspase-3 and decrease in VEGF and survival. In addition to this link cap, which is androgen-dependent tumor, we have also developed another mouse model which is androgen independent, using injecting PC3 luciferase cell in the mice, and again we have tested with combination of nimbolide and docetaxel. So we can see a significant decrease in the tumor burden without any adverse effects. So in future, we are currently looking at some of the other studies whether nimbolide can potentiate the anti-cancer effects of other FGF2 drugs like androgen antagonists. And we are also doing a large-scale study looking at the pharmacokinetic parameters and chronic toxicity with nimbolide before moving to phase 1 clinical trial in prostate cancer patients. So these are some of our works that we have published, 2 studies on Imbolide, one on oxidative stress in ACT model and one in enhancing the effect of docetaxel via modulating NF-kappa B pathway. So in conclusion, I will like to summarize that we are using these 4 intermittent transcription factors, and we feel that they can be used for as ideal targets for cancer treatment and prevention. I would like to acknowledge some of my lab people who have done this work and my current collaborators. Thank you, and I will be glad to take any questions.
Thank you, Dr. Sethi. So if anybody has any pressing question, then anybody has any question?
Hello, Dr. Sethi, it was a nice talk. I saw the data that you have this nimeloid synergistic with docetaxel, but can you comment on its synergistic impact on other chemos also, like cisplatin and etoposide, if there is literature existing on that or in your experience?
There are some studies, but I'm not sure whether it is in prostate cancer, but in other cancers, there have been studies that it can enhance the effect of chemotherapeutic agents. So some studies have been published, but our current aim is more to look whether it can also enhance the effect of some of the targeted therapies like androgen blockers, which are being used for prostate cancer and castrate-resistant patients. So it is our current aim. But yes, there are some studies, maybe not in prostate, but other cancers with different chemotherapeutic agents.
Okay, thank you.
So if there is no other question, then thank you, Dr. Sethi, for an excellent talk.
Thank you.
I hope it gives the synergistic effect. So thank you very much.
Thank you.